Alright, it took me a while to, well, took me a while to get it started, but I finally have it figured out and running. Are you kidding me? Don't open in any format. Alright, let me make sure. Hello? Alright, you guys can hear me? Okay. Alright, here's the problem I have right here. I'm gonna paste it in the paint. Let me just zoom in, make sure I get a good snip. Print screen. Alright, this is my first video, so it's not gonna be perfect, but as time goes on, I'll make it better. This is my scan, by the way. Alright, so let me paste it in the paint. Alright, let me get rid of let me start with just this piece first right here, sketch the curve. So, crop. So this is the function we're given right here. Y is equal to square root of 1 minus x squared over x, and we're asked to sketch it. Whenever you're sketching curves, the things you want to know are the domain and range, the roots, is it even, odd, or neither, vertical, horizontal asymptotes, where the maximins are, where the function's increasing and decreasing, and where there are inflection or concavity points. So I'm going to explain all that here. So the domain, that's just where it's defined. We know we can't divide by 0, so, and we have x there, so x can't equal 0. That's where we get this part from right here. And then the radical, we know we can't take the square root of a negative number for all practical purposes. So we want to find what this is greater than or equal to 0. And to do that, it is just, well, hold on. Didn't know my panel's going to be that sensitive. So if we have 1 minus x squared, we want to know where that's greater than or equal to 0. So square both sides. 0 squared is just 0, so it stays the same. And then we're going to subtract 1, divide by a negative, and then when we take the square root, we'll have positive negative 1. So x has to be between it has to be less than or equal to 1. When we divide by the negative, that shouldn't be an equal sign right there. That should actually be, let me fix that. Should actually just be one of these, but I have to flip it. So flip vertical. Let me flip vertical one more time. All right. X has to be less than or equal to positive negative 1. So that's the same thing as saying, if you want to write an interval notation, that's f of x, y. And then x isn't equal to 0. This is set builder notation. My bad, I meant to use the other one. Let me fix that. So this is the domain with set builder notation. We have D. From -1 to 1. -1 to 0, union, and then 0 to 1. That's the domain. Our defined range, yeah, this isn't something we normally solve for anymore once you make it to this level, but I had to refresh myself now to solve for it too. But all you want to do is switch x and y and solve for y again. And then basically you're just doing the same thing. Where is the function defined? And the numerator is just 1. That means nothing really matters there. We have x in the denominator. We know we can't divide by 0, but this will never equal 0 because x squared, wherever you put, it's squared, so it's going to be positive. Then you have +1, and you just have a radical, but it's never going to be, the lowest it'll be is 1, so you don't have to worry. So the range is all real numbers. All right, we'll take a look at the next part. Okay, let me go back over where I was before. I thought I had 2 of these open. All right, since I can't get to it, I'm gonna have to, I'll just crop it one more time. All right, now that we know the domain and range, the next thing we want to find is there any asymptotic behavior for the function? So this function is y equals square root of x minus 1 minus x squared over x. So we know we have a vertical asymptote whenever we try to divide by 0. So since we only have x, we should know right away that it's going to be an asymptote at x equals 0. So I wish I could scroll up on here. All right, so if we look at the function, I'll just rewrite it since it didn't get cropped. Yeah, I don't know if I want to do this. Copy, go back there. All right, so asymptotes, yeah, you have a vertical x equals 0, and then horizontal, there are no horizontals asymptotes because if you try taking the limit, I'll do the limit on the side. Horizontal asymptote, we want to find a limit as x approaches infinity. And we have square root of 1 minus x squared over x. So we want to factor out the x's, so we can take out an x from the numerator. That means here we're going to have 1 over x squared minus 1. So when we plug in infinity, these two x's cancel, this goes to 0, and then we just have negative 1. That means there is none. We have none. There's no slant either. So that's all there is for there. Now that we know the asymptotes, we can find where it's increasing and decreasing. And another thing before you draw the graph that'll help you is to realize that this function is odd. The way you know it's odd is because, let me clear space. So we know odd is when you plug in negative x and you can factor it out and get the same thing. That's when it's odd. And when it's odd, you're symmetric about the origin. So if you look at the graph that I drew, let me see where it went. I may have closed it already. Alright, so here's the graph right here that I drew. You can see that it is symmetric about the origin, so that means it's odd. We can flip it, and then I'll just prove that mathematically. So f of negative x is equal to square root of 1 minus x squared over x, and then you plug in negative x inside the radical. You're just going to get anything squared. Anytime you put a negative inside of a square, it's always going to be positive, so it's not going to really affect anything. So we can leave it the same. But in the denominator, we'll get negative x, which means we can just factor out a negative and we'll have the same thing. So we know f of negative x is equal to negative f of x. Let me switch my pen. This isn't the size I wanted. Let me see if anyone's watching this live stream. No viewers? Okay. Alright. So I'm going to do the first derivative test. Find the first derivative so we can find what's increasing and decreasing. Alright, so this is what we have here. So we got to do, there's more than one way to get the answer. You could do product rule or you can do quotient rule. I use quotient rule because I felt like it was going to be the most simplistic one for me. So in case you forgot, the quotient rule for differentiation is gf prime minus f of g prime over g squared. And then I did the work up here for the first term. This is the function in case you forgot it. 1 minus x squared over x. So we put in g, that's just x. I went ahead and combined it with the x you get when you do chain rule. So you have 1 minus x, which is a negative half. A half comes down from differentiating, and then you do chain rule and you get a negative 2x. I just put the other x over here, that's why it's squared. And then you have minus, and then f is just as is, and then we take the derivative of x, it's just negative 1 over x squared. So basically when you do this, this negative 2 and this negative 2 cancels. You multiply the whole thing by 1 minus x squared. So that way this turns to 1, this becomes squared, and you just get 1 minus x squared. So now you have negative 1, and then for the plus x squared, that cancels with this over here because you have a negative 2, so that turns this negative. the 2 cancels, but the negative doesn't. So you just you wind up with, where did I write the answer? Let me erase some of this first. Wrote it right here. Yeah, I just got in the way. -1 over square root of 1 minus x squared over x squared. So we can use this to find where the max and mins are and where it's increasing and decreasing. So this has roots at 1, -1, and 0. But if you try to do the number line for it, -√2 over 2 and √2 over 2, I forgot to include 0. The function's decreasing everywhere because when you plug something in for either of these two x squareds, it's always going to be positive, but you have the negative up top, so it's always decreasing, and that's shown by the graph right here. So now that we have that, that's the last thing we need. Now we just need to find, we need to do the second derivative test so we can find where the function is, where the inflection points are, and what the concavity is. So I'll do that right now. Alright, so you can ignore all this. We already know it's odd, we know where the roots are. Here's the interval for what's increasing and decreasing. I'll leave that right there in case you haven't got it yet. So the function that we have before we do the second derivative test is y prime is equal to -1 over x squared over 1 minus x squared. What I did to solve this was I did quotient rule again. So we have f prime because it's g times f prime. F is a constant, so we're going to get 0. So we're just going to have minus. So I skipped the g and f. I'm on the f and g prime. That means you're going to have +1 because that negative and that negative cancel here. And then you got to do product rule, so you get 2x times √1 minus x squared. If you want to see the work for it, it's down here. I don't want to rewrite it. I just wanted to get the ball rolling in case you were confused. So you're going to get 2x minus 2x cubed minus x to the third. You can factor out an x and have 2 minus 3x squared. And then square the denominator and you get 2x squared and then 1 minus x squared to the 3/2. So I'm going to skip most of the algebra because it's just, you should know how to do the algebra if you're in this class. So inflections, when you solve it, we want to know where it's 0. Where it's 0 is where the inflections are at. So 0, because you have x squared. 1 minus x squared, because if you put 1 or -1, if you put 1 or -1 inside there, you get 1, and then that gives you 0. So we know we have them at, yeah, here's the number line. So it should be concave up, I think here, 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 and here. √2, 3, 1. So wherever you do the number line test and you get a positive value, that's concave up. Concave down is when you get a negative. So I have to cut this video early. Have a good day.